video talking about the kind of nuts and bolts of what is a hypothesis test. So it starts off with a question. We have this question. In NFL overtime games, does the home team have a distinct advantage? So let's think about what that is. That gives us two hypotheses. The first hypothesis is that in an overtime game, the probability that the home team is going to win is equal to 0.5, and the alternative hypothesis will be that the probability that a home team is going to win has got to be bigger than 0.5. The alternative hypothesis is what we're claiming there. The null hypothesis is the one that has equals in it. Okay, so what people did is they went out and they looked at 428 NFL games. Now, I'm not going to talk about what their X was yet, how many of those NFL overtime games were won by the home team. Before I do, I'm just going to look at that. N is equal to 428 and that P. Somewhere there is a P hat, which is if we were to look at, in some kind of infinite universe, infinitely many sets of 428 NFL overtime games. Even if there is a home team advantage, there would be a distribution of how many of those would be won by the home team. And if there's not a home team advantage, that would be the case too. So even if this null hypothesis were true, this wouldn't be the same every time. This would have a distribution. So what we're going to do is we're going to look at that distribution under this null hypothesis. What that means is the distribution would look normally distributed, and the center would be 0.5. Sometimes you'd win a little bit more than 50% of the games, sometimes they'd win a little bit less than 50% of the games. What we ended up getting was a P hat of 240 wins for the home team out of our 428 games. So that is equal to about 0.561. Question, is that a long way away from 0.5 or is that a short way away from 0.5? That's what we have to worry. That's what we will be deciding with our hypothesis test. We're going to shift over to stat key now to get some more evidence about that.